Hello everyone, welcome back to my channel, and this is Hitesh, and today we're gonna continue on our project. Today's topic is DHCP, but before we get into the topic of today, I just want to tell you guys why I've not posted anything for the last month. Well, the reason I didn't post anything is because my university started again. I'm doing a degree right now, so that course the program started in September, and I just couldn't find any time to continue on the project, but it is something that I want to complete, and I want to see to the end, and here we are. I'm going to configure, not configure, but, well, we are going to configure DHCP, but I'm going to take you guys through the process of DHCP first. So, to this agenda, we introduce DHCP. We're going to look at something known as a DORA process, and we'll also look at another term known as DHCP Relay Agent, and then we will configure DHCP in our network from before. So, what is DHCP? DHCP stands for Dynamic Host Configuration Protocol. I believe you have done this before, but we haven't gone this much in depth, but I wanted to go in depth for this one. So DHCP stands for Dynamic Host Configuration Protocol. It is used to dynamically assign hosts an IP address and configure the host with some extra information like default gateway and DNS server. The thing that we didn't go over last time was that it uses a process called DORA. DORA stands for Discover, Offer, Request, and Acknowledge. This is easy to remember if you know Dora the Explorer. Just her name, is the abbreviation for this. So, what is DORA? I'm going to explain the four processes. The first process, the Discover, it's a message. The DORA process consists of four messages: Discover message, Offer message, Request message, and Acknowledge message. The Discover message is a broadcast message sent from the host to all DHCP servers in the network. The purpose of this message is to locate at least one or more DHCP servers. So essentially, when we configure it, I will also run Wireshark, and I'll show you how this works. But when we start our device, it will start asking for a DHCP message, and you will see, hey, Discover messages pop up. And it's essentially a broadcast message, so it's all Fs, and it's 255, 255, 255, 255. And it's basically trying to find a DHCP server. The next message is Offer. An offer message could be either a unicast message or a broadcast message. But it's a message from the server to the original host, and it's the reply of the Discover message. And practically the reason of this message is to tell the host that, hey, you contacted me for an IP address. I have a potential IP address you can use, and this is the least duration you'll get. And that's it. And when the host gets this message, it will say, okay, this is good, this is nice, but it will also, at the same time, it will also get multiple messages, multiple offer messages, if there are multiple DHCP servers in the network. So it will look at it, and it will say, okay, I have these many requests, which one was the fastest to me? It will prefer whichever message was the fastest. So, okay, this one was the fastest message. So let's say server A, B, and C sent out 3 offers to host, and host will say, okay, host will say, well, okay, server B was the fastest one, so I'm gonna send a request message to the original offer of server B. So the host will send a request message, and the request message is the broadcast message, and it will send it to the server to accept that potential lease of the IP address. it is a broadcast message again because the host might receive multiple offers from multiple servers, and sending a broadcast request message will eliminate all other offers. So essentially what is happening in the request message is it is accepting server B's offer, and it's rejecting server A and server C's offers because they are slower than server B. And then something else happens. An acknowledge message is sent from server B to an acknowledge message is sent from the server to the host, and it could either be a unicast message or a broadcast message. Sometimes it's a unicast, sometimes it's a broadcast. And it's essentially to acknowledge the request message and to let the host know that, hey, your release has started and you have now been configured with this IP address and with this default gateway or DNS server or all of the other options. We will go over the options as well. There's a lot of options in a DHCP message that you can configure. So this is the DORA process. We will look at it again. I will run through this the DORA process in Packet Tracer, and then we will actually configure our DHCP server in GNS in our actual project. But I will definitely go over this DORA process and simulate it and show you guys how it works. But another question that comes up is that the DHCP message, the DORA process, is only good if the server is in the actual network, right? But what if the server is in a different network entirely? What happens then? How does a device with no IP address communicate with a DHCP server that is in some other network? If that is the case, then we use something called as a DHCP Relay Agent. And the purpose of the DHCP Relay Agent is basically to facilitate communication between the host and the DHCP server. And yeah, so like you see on the screen, is basically there when a DHCP Relay Agent may be used to follow the DORA process to configure a host if a DHCP server is not present in the same network as the host. The main purpose of the DHCP Relay Agent is to follow the requests and replies, so between the server and the client. So and we will configure this as well, when the DHCP Relay Agent is doing communication, it will actively send replies and requests to and from the server to the host or from the host, and it will practically be doing the host side of communication by itself, but it will also let the actual host know that, hey, this is the reply from the server, do whatever you want with it. And then host will say, okay, I accept this offer. It will send out the request message. The request message will be forwarded by the relay agent to the server. So I'll also show how this goes. Essentially, it's a very simple protocol, the DHCP protocol. Once you fully understand how this works, because it takes a long time to understand how this works, but when you do, of course it becomes simple. The hard part is the understanding of it, right? Because the DHCP Relay Agent is something entirely new. Even it took me some while to understand it as well, but it's just practice. You got to keep practicing, and you will understand how it works. Same with DNS. DNS is something that I still don't fully understand, but it's something that I'm learning. Okay, so let's get started on the configuration. The first step that we will look at is the DORA process. Then we will look at the relay agent, and after that we will configure our own network, our Windows servers, as a DHCP server for each of the LANs. So we're gonna start with packet tracer, and I'm just gonna show the two concepts first. I'm gonna use packet tracer because it's easier to visualize the packet transfer, or the way the packets work. So first off, let's configure our router. I'm using Cisco right now, but when we switch over to our actual topology, we'll be doing this on the Windows server. So Conf-T, and I'm going to create a DHCP server on this router. But first we do that, we're going to configure this interface to be active, right? So I'm just going to actually extend this as well. Okay, so I've extended the entry of this. Okay, so we're going to say interface gigabit. I don't think you can see this, so let me just move this around back here. Okay, so interface gigabit 0.0.1 I'm going to say IP address 192.168.0.1 255.255.255.0. no shut. And after that, I'm going to say IP DHCP excluded addresses. Oh, we're still in the interface command, so IP DHCP excluded addresses 192.168.0.100 to 192.168.0 to, let's say, 150. And I'm going to say IP DHCP pool pool_1 network 192.168.0.0 255.255.255.0 and default router 192.168.0.1. Let's see what other stuff we have. The default router DNS domain name network no to negate a command and options. But that's it. That's all we need. And we're gonna do this. And before we go to our simulation, let's check if we have handed in any other. So I do show IP DHCP bindings. We have nothing right now. So we're gonna switch back and I'm gonna show simulation, show none, and we just want to see DHCP right now. So I'm going to go inside here and I'm going to go DHCP, and you see we have created a first packet here, and you see constructs a discover packet. Actually, let me just make sure that it looks bigger so it's easier to understand. Hold on a second. Alright, so the first packet that we see is a DHCP packet, and it says it's a discover packet. So the DHCP client constructs a discover packet. So if you remember from our DORA method, the first D stands for discover, right? So DORA, we see layer 3 IP address, source IP is 0000. Sometimes, well, most of the times it'll be 0000. And then destination IP you also see is all 2255s, which means it's a broadcast message. Let's see if it says that here. The device has the source address to 0 IP address is in the same center. The device has the next hop destination. Layer 2 Ethernet header, we see the MAC address of PC0. And all Fs, meaning it's a broadcast message. So the next hop IP is a broadcast. The R process sets the frame to that broadcast message. So let's see when it goes. I'm gonna close stuff up over here. Again, we see it starts to decrypt the packet, and the first is the frame destination MAC matches the receiving port's MAC, which is all Fs, and de-encapsulates the PDU and goes to the next layer, which says, well, it has an entry for that device, And if you go back to layer 7, it will say, hey, the DA packet is a DHCP packet. The DHCP server processes it. It finds out that, hey, this packet is a DHCP discover packet. It says, hey, we do not have an existing binding to this MAC address, and it looks up for DHCP pools within itself to see if there is an available IP address. It says, hey, find the next available IP address in the pool. So it says, okay, we have found one IP address, and we're going to send it to the PC. And if you see the out layer, it said the DHCP server constructs a DHCP offer packet and prepares to send it out. So now we're on the second step of the DORA process, the offer packet. So let's see. It sends the offer packet to PC0. Again, fast Ethernet 0 receives it. Layer 2 will decrypt. The source IP, packet destination IP matches the service packet, and we see client sees the DHCP client received a DHCP offer packet. So it says, okay, this is a offer that it has received, and we also see that it's using 192.168.0.1 just to say that, hey, I'm communicating with this one right now. So layer 7, you see the DHCP client receives the offer packet. It constructs a request packet for the I was wrong. It uses 0.1, so that was the IP address of router 1 to destination all IP. Oh, sorry, I think I was talking on mute for this entire time. Well, okay, so basically it sends out the request message to PC, to router, and first it comes in as the the layer 2 we see as the source MAC being PC0's MAC, and all F's meaning it's a broadcast packet. So, and then again, layer 3 IP, we see source IP quad 0, which means it still hasn't taken up the IP yet. And we see quad 255, again saying that this is a broadcast message. In layer 7, we see it's a DHCP packet, and it says the DHCP server received a DHCP request packet. And what it's going to do now is it's going to bind the requested IP address to the host's MAC address to uniquely identify, hey, I am assigning this IP to this specific host. And next, it sends out an acknowledge packet. So you see, sends out an acknowledge packet to the host. So again, the source IP is 0.1, destination IP is quad 25. It's again a broadcast message because here we see it is the source MAC of the router and all Fs, and it sends it out and it receives it, and we see the packet is a DHCP packet, process it, receives a DHCP acknowledge packet, receives an packet, and sets its IP address configuration. So here the process is complete. So now if you go here, we see the IP and we can start communicating. We see 192.168.0.2, and if we go back to our command prompt and if we ping 192.168.0.1, we can talk to our default gateway. So this is basically how DORA works. We saw the communication work, but now we're going to look at the scenario where the DHCP server does not lie on the same network. Right now, they're on the same network, but we're going to look at what happens when they're on different networks. So I have, again, a router here, and I'm going to make this router my DHCP server. So let's go ahead and do that. First, I'm going to configure this. Enable conf t, interface G000, IP address 192.168.0.1, 5.255.255.0, no shut, and interface G001. Let's see if that was right. 001, yes. I'm going to say IP address 192.168.2.1, 255.255.255.0, no shut. And I'm going to go on the other side, and here I'm going to say enable configure terminal, interface G000, IP address 192.168.2.2, 255.255.255.0, no shut. We're going to do a quick ping to make sure we can talk to our main guy, and we can. Okay, so now we're going to make the server, the DHCP server for this network. So let's go ahead and do that. So first I'm going to do IP DHCP excluded addresses. Excluded. Oh, we're still in the config mode. That's IP DHCP excluded addresses 192.168 0.0, 255.255.255.0. IP. Oh shoot. Yeah, we did the wrong command here. Sorry. So no IP DHCP 0.100 to 192.168.0.150. IP DHCP pool underscore pool 1 network 192.168.0.1 .255.255.0. network command, I did it again wrong. Default router, I'm going to say 192.168.0.1. Okay, so now we have configured our server, but the one thing that we're missing is, okay, I'll make sure it's static. Well, the DORA process only works between one network, right? So let's say if this router wanted an IP address, it would be able to do so because it's in the same network. But right now we need this guy to get the IP address from the DHCP server, but it cannot do that because it does not have an IP address, because the server that lies on a different network. So how do we do that, right? The way to do that is a relay agent, and an easier way to, first of all, you need to understand where to put the relay agent. A a relay. Well, let me also explain what a relay agent is. A relay agent is basically an agent, a middleman between the DHCP server and the DHCP client. So right now, router 0 is our relay agent, the middleman. So yeah, the server then does so the relay agent is going to relay the communication between the client and the server. So let's actually see that happening right now. We're going to configure router 0 as the relay agent, and then we'll see the communication happen between the server, the relay agent, and the client. Another thing to remember about where to put the relay agent is that it's always on the downstream port. So one way to remember that, if let's see, this is the upstream, right? The server is up here, our relay agent is down here, and our PC is down here. The relay agent is always going to be on the port that is facing down to the host. It's never going to be up to the server, it's always going to be down to the port, down to the host. So let's configure router 0 as the relay agent. So to do that, we go back to interface gigabit 000, and we do IP DHCP, and let's see question mark. Wow, okay, so the command to do that is IP helper address. So let's say IP helper address 192.168.2.2. So now we're going to start our simulation again, and we're going to see the transaction between the DHCP server, the client, and the relay agent. So it sends the first packet. The first packet is always the DORA packet. You see, it's a discover packet. Layer 1 receives it, sees the next hop IP as the adjacent. In the in layers, when you're de-encrypting the packet, it says the DHCP server does not have a pool configured for the receiving port. It drops the packet. And it's, well, the next one, it says, hey, helper criteria. When you see it says matches the helper criteria, the device forwards the packet to the helper address. So it's going to forward the discover message to the DHCP server. So it forwards it, and it sees, hey, the source IP is 0.1, destination IP 0.1. The packet is a DHCP packet, server processes it, receives a DHCP discover packet. The DHCP server does not have an existing binding to this host. It looks up a DHCP pool, finds the next available IP address for this pool, for this host, constructs a DHCP offer packet, and prepares to send it out. So it's going to send back an offer packet. Again, I think this is going to be again a discover packet. Oh, I think we forgot one thing to do here. We forgot to tell router 2 where the network is. So now we got to do one more thing. So IP route 192.168.0.1, 0.0, 255.255.255.0 lives out of G000. And we're also going to say 192.168.2.1. Okay, now we should try it again. Static. Let's try that again. DHCP sends out the DHCP packet, the discover packet, the DHCP discover packet, and router 0 of a relay agent is going to send the packet, the DHCP packet, to our DHCP server. It receives it and it says okay, checks out. Server constructs a DHCP offer and prepares to send it back, and it's going to send it back, and it sees okay. So another thing you will notice, every time the packet is received on router 0, our relay agent, it will never say anything about layer 7 here. It will always be layer 1, 2, and 3, because it's not destined for this PC, right? So it doesn't need to decrypt the entire layers. So again, source IP is this 0.1, the frame and everything like that. It sees the packet is a reply from the helper address. The device forwards the packet back to the original sender, sends it out to broadcast everything, all Fs, and it sent it out. And PC0 receives it. It says, okay, the packet is a DHCP packet. It finds that it's a DHCP offer packet. It sends another message to now reply to the original offer packet. It says, hey, it's a request packet, and it's going to again send it, or it's going to broadcast it again. So it's going to broadcast, and we see router 0 of a relay agent receives it. Now it sees, hey, it's again a, sorry, where does it say that? Oh, here, it should say that. Okay, it says, hey, again, this is a DHCP server packet. I don't have a DHCP server, but I know where one could be. So I'm going to use the helper criteria to send it to that address. So it's going to send it to that IP address, 2.2. 2.2 receives it, and it will say, okay, it's a request packet. Sorry, it's a request packet. The DHCP server then binds the requested IP to the host's MAC address. Yes, host MAC address, and it starts to send it back. Sends an acknowledge packet to the host. Again, everything same. Goes back, and checks out. It says, hey, and it says it's configured IP address. So that's that. So that's how a relay agent works. Now we have a IP address. If you go to default, and we see 192.168.0.5. So it's random here. So now, what if you want to see the MAC address here? We see the MAC address 0060 55C2C. So let's confirm here. So do show IP DHCP bindings, and we see that it has the MAC address binded to the IP address that it's been leased. So this is how a relay agent works. This is what we're going to use in our topology relay agent. So now we're going to move over to our actual network, and we're going to start configuring our DHCP, our Windows servers as a DHCP server. We are also going to remove the previous DHCP pools from our Cisco routers and configure them as a relay agent. So let's go ahead and do that right now. Alright, so let's get started on the actual project. Here we have the actual project I've been working on. I have kept the bottom two switches on off for now, just because I want to save on the RAM. First things first, that the one thing that I've already done is I went ahead and I've removed all of the DHCP pools from our DHCP servers, just to make sure that we don't have anything colliding with the server that we are going to start today. So just to recap, we had our DHCP servers on our switches here. We had we had 3 DHCP pools here and 2 DHCP pools here. We had 2 DHCP pools here and 2 DHCP pools here. We have gone ahead and we have removed that, remove those pools, which means that no device, so all of these user devices like the Kali Linux and these PCs here will not be able to get DHCP address right now because there is no existing DHCP server. As we saw from the packet tracer example, we're going to need a relay agent, right? Because I want to make our Windows server as our DHCP servers, and because they're not on the same network as the as host, we're gonna have to allow them to we're gonna have to allow the switches to we're gonna have to allow the switches to route that message to the servers. That's especially important in this scenario down here in site 1 because we have so many switches. Because we have this switch does not know where this address is. Or, well, it does, but it won't be able to send a broadcast package that far away because technically these are routed, right? So we need to tell them that, hey, this is routed. Or sorry, this is a DHCP packet and this has to be sent here. Well, let's go ahead and do that first. So we're going to configure our switches as the relay agent. So SW1, SW2, 3, site 2 SW1 and site 3 SW1 as our relay agents. So let's go ahead and do that first. We're going to start with SW1. We're going to do a do show IP in brief to see what interfaces we have. Right now they all say down, but only VLAN 30 is up. VLAN 30 is up. Why? Well, there must be some reason why. But yeah. Okay. VLAN 40 is up here because that's a server it's connected to. Okay. Alright, let's do this. So here we wanted to make sure that the downstream ports have the necessary commands. So we're going to go to interface VLAN 10. We're going to do IP helper address. If that was the command, let's just check again. IP helper address, yes. So IP helper address, and we're gonna put the IP address of site1 DC. So let's actually check what the IP was. Site1 DC is over here. Command prompt. The IP is 40.250. So we're gonna go back here. 192.168.40.250, and so you're gonna do the same thing for other VLANs as well. So we're gonna first shut and then no shut. Interface VLAN 20. IP helper address 192.168.40.250. Shut no shut. Interface VLAN 30. IP helper address 192.168.40.250. Shut no shut. And let's check do show IP int brief, and I just want to confirm that we haven't accidentally put any of them permanently down. Okay. Alright, so we're gonna go back here to this server interface VLAN 40. Interface VLAN 40 is the DHCP server, so even if there is someone here in this VLAN, we should say IP helper address 192.168. Technically, you do not need to do this. because what happens is that when we have VLANs, if you remember from our VLAN video, VLANs is basically separating the broadcast storms, right? The broadcast domains. So in VLAN 40, where the server is already located, it will automatically get that DHCP discover message because it is in the same broadcast domain. So technically we don't need to do this, but I will do this regardless. If we see any problem come up, we know where to look. Interface VLAN 50 IP helper address 192.168.40.250. Shut, no, shut. Do show IP into brief. And we should have everything here. Okay. Alright, so let's go and start our server here first. So Site1DC we have, and I want to start my server manager. So server manager. Let's also expand this so it's more clear. So server manager, wait for it to load. Okay, so our server manager has loaded and has completed its checks. So when we go back to notification, we left off on this message where it said complete DHCP configuration. So let's go ahead and start that now. You got servers, domain join or not. Okay, so pass out the credentials to be used to authorize the DHCP server in ATDS. Use the following user credentials: username, well, yep, and commit. Close, and we just did that. And when we go out, we have our DHCP console here. So let's start our DHCP console. And we are here in the console. We see some new stuff, So an IPv4. We have all of these here. So let's go ahead and start a new scope. So we have our new scope wizard. Let's continue. Let's name this as VLAN 10. And description DHCP for VLAN 10. Next, start IP address range 192.168.10.0 and IP address range 192.168.10.254. Next, 10.1, sorry, 10.1. Next, we want to exclude the last 15 if we remember from that time. So 192.168.10.240 to 192.168.10.254. Add. Next. 8 days. Let's configure this scope options. Router, our router for now, it was 192.168.10.253. Let's confirm that actually. So our port channel interfaces, sorry, not port channel, do show I'll standby. Actually, I think it was do show stand. So let's go ahead and see if we can see it. So exit, show standby. show standby brief. So our router was 252. I'm gonna add that for VLAN 10. Next, parent domain, that one, yes. Let's check. That's fine. Let's go next. Don't have a Win server. Activate scope, yes. Finish. Display statistics. Close and refresh. Okay, we have our first scope, server for VLAN 10. And let's see if we can get this PC to have the IP address. So config. So let's see. I was checking around what was happening and I saw that it was just the switches were taking a long time for them to boot up. So now you can see we have an IP address 10.1, and let's look at the process. So I ran packet tracer, or sorry, not packet tracer, a packet capture here, and we have all these discover messages that were being sent out in the beginning, but they were not being replied to because the switches were not fully active yet. So they became active around here, and you can see the first discover message got answered. So we see here, let me see if I can zoom in a bit. We can't. But here you can see that the discover message, we see the frame destination broadcast is all Fs, source is our own PC. We see IPv4, source all zeros, and destination all 255s. And we also see a UDP. DHCP is a UDP protocol. The DHCP client will always use a source port of 68 and destination port of 67. And in the next message, you'll see this being reversed. So another thing to realize that source port and destination ports for DHCP are two different ports. In like SSH and FTP, they are one singular port, but in DHCP, they have made it different. Then you see the actual DHCP discover message. You see the DHCP discover message type boot request, and we see something known as a boot P flag. Boot P flag used to be the old version of DHCP, and you see it's a unicast message. So we see client IP address, so our own IP address is 0000, next server IP address, relay agent IP address, it does not know anything, so it's a broadcast message. We see some options, so option 53, DHCP message type, discover message. We see option 61, client identifier. We do not care about all these host name, we don't care PC1, and option 55, and. So let's look at the next one. From 10.254 to 10.1. Again, we see 67, 68. It's a bit different. 67, 68. Sorry, source port 68. Destination port 67. You see it being reversed here. So source port 67, destination port 68. So again, you see a boot reply. message number second message. So if you go back to the discover message, you see boot request 1, you see boot reply 2, and now it identifies some IP addresses. So it sees, hey, this is the request that it is given me. Oh, sorry, that's the offer that it has received. It says the next server is 40.250 and relay agent is 10.254. 10.254. So yes, and we see again some options here. I'll just close these all again so we can see them better. And there we go. So now we have some more IP or some more options. We see some subnet mask option number 1, what the subnet mask of the IP address is. We see some renewal time, 4 days. We see some rebinding time, 7 days. We see some DHCP server identifier. So it says, hey, I am your server. If you want to renew your IP address again, contact me here. It tells you the router, your default gateway, 192.168.10.252. It tells you your domain name server, DNS server is again 40.250. And it says domain name is hagarwal.ca, so my name or my server. And then we have a request. Again, you see 68 to 67. It was different here, 67 to 68. Now it is from the client. Client port is 68 and the server port is 67. And it has everything here again, same stuff. Host name, DHCP message size, subnet mask, router, domain name, host name, domain name, broadcast address, network time, NTP protocol. That's something completely different. And it just basically says, hey, this is acknowledge, boot reply 2. You see boot request 1, then boot reply 2. And this is again an acknowledge message. So same thing, hey, this is your this is fixed, you are now for 10.1. So if you were to go back here on our web term and we say ping 8888, we should have internet. So we weren't able to do that before. And let's go ahead and configure the servers for other VLANs. So let's go ahead and configure. Actually, we can copy this. Let's see if we can. Events. No, we can't configure it. Okay, so that's fine. We can always just do new scope. And next, we do one for VLAN 20. DHCP for VLAN 20. Start IP 192.168.20.1 and 192.168.20.254. Next, exclusion 192.168. Wow, so 192.168.20.240, 192.168.20.254. Next. Router 192.168.20.252. Next. Finish. 250. And let's configure one for 30 as well. VLAN-30. DHCP for VLAN 30, 192.168.30.1, 192.168.30.254, exclusion 192.168.30.240 to 192.168.30.254. Router 192.168.30.252. So we have 30, 20, and let's configure 2 more for 40 and 50. So VLAN 40, DHCP for VLAN 40, start 1 and 2, 168, 40.1, 1 and 2, 168, wow, 1 and 2, 168, 40.254, 254, 192, 168, 40.240, 192, 168, 40.254, 192, 168, 40.252. And let's configure the last one for VLAN 50. So VLAN 50, DHCP for VLAN 50, 192, 168, 50, dot 1, 192, 168, 50.254, 192, 168, 50.240 to 192, 168, 50.254. Oh, I think I messed up something. Let's go back, check, next, 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 192, 168, 50.252. And we have our servers here. We're gonna go ahead and we're gonna refresh our server, make sure that it is all check marks. And as you can see, we have all DHCP servers, they're all active. You can obviously also check, you can display statistics, 10.1 display statistics. We have one in use by our VLAN. We can see address lease. We can see the hostname PC1 and lease expiration and unique identity, network access protection, full access, everything like that. So that's full access to our server. We have a reservation. You can see the reservation if you want to add more. There should be reservations here. Refresh. I think we are, yeah, so here it's excluded reservations if something we wanted to exclusively have. 10.1 to 10.254, and this is the excluded range. We have our scope options here, so we see our router is 10.252, we have our DNS server and DNS domain name. Same thing for VLAN 20. If we do address pool, address lease, there should be 20.pc2. We have no reservations. Scope options, router is 20.252 and 40.250. Same thing for VLAN 30. Address pool, we will have the exclusion range from 240 to 254. You should have one lease, 230.1. No reservations. And scope options again, you see 3.252. And if you ever make mistakes, you can always come back here and you can always edit it. So it's not something that is set in stone. It's always changeable. Address pool, 40.254. Lease, we don't have any lease because there is no anything configured. Yeah, so reservations, you can see it tells you what it is, what it should be used for. A reservation ensures that a DHCP client is always assigned the same IP address. So if you want to do this, you can do this. There's no big difference to it and everything like that. So this is our main server. It is working, and we have DNS server working properly. And let's also take a look at our DNS server. right, and let's go to our next servers. Actually, let's also start these ones. Well, if we just want to configure the servers, right, so let's just configure it and save some memory. So Control Alt Delete. Configure our next server. Let's go ahead and do that part right now. So do show IP and brief. Okay, so let's go ahead and to do this, let's also confirm the IP address of our Site 2 DC is 140.250. Let's also start our DHCP or our server manager here. So interface VLAN 110, IP helper address 92.168.140.250 into VLAN 120, IP helper address 192.168.140.250 interface VLAN 130. Okay, we're back. So let's complete our DHCP configuration here. Okay, next. That's not good. Okay. Sorry, what is happening right now? Next. Commit. Done. Close. And let's start our DHCP console. I did want to check something with our server here. We had one VLAN 130 and VLAN 140. So we will make two VLAN 120 and 130. So let's go ahead and make a new scope. And VLAN 120. We're not going to make all the scopes today. It just takes a long time. 120.1, 192.168, 120.254, 192. Let's actually check the IP address that we had. 254, because we don't have anything here, right? So 254 is the only one. So yeah, 254. 254. Add. Next. And VLAN 130. So we have two scopes over here. We won't have anything here to test it with, because if I was to turn that on, it will take some time for it to turn on. So we're not going to test that, but we know from our experience here that it works. Let's go and do the same thing over here. So I think my side 3DC again is down. So let's go and wake it up. And here we are. Server manager is already open, so nice. It's already done processing. It takes some time because we don't have much RAM given to the server, so it's taking some time for it to load data. But yeah. Site 3 is usually a bit weak too. Okay, so let's go back to our site 3 here in phase conf t to show IP int brief, and let's go interface VLAN 110. Oh, 210, sorry. IP helper address 192.168.240.250 into VLAN 220. IP helper address 192.168.240.250 into VLAN 230. IP helper address 192.168.240.250 into VLAN 240. IP helper address 192.168.250, sorry, 240.250 into VLAN 250. IP helper address 192.168.240.250. Do WR. So let's write that to our memory. Okay, so let's see if this is responding now. Next. So we're back here on our server, on our third server, and wow, sorry, let's also make DHCP binding, DHCP scopes here. I was going to say that VLAN 210, 192.168.210.1. believe it was for this one we had only had 210 and 220. So yeah, let's make 220 as well. New scope. VLAN 220. And 220.1. Okay, so we got 2 servers, they're both active, and that's about it. We have a fully working DHCP server in all 3 sites. All of these PCs here, VLAN 30, if you were to go back to VLAN 30 here and do an ifconfig, we see we have a 30.1. We can ping around, we can ping 192.168.240.250. We can ping this server on that side. We can ping the server on site 2, so 140. That 250 should be going. I think there's some. We may not have a route to 140. That's fine. Well, we have some things that are working properly. But alright, that's about it. That's how we have our servers working. We're gonna do one last write to save our configurations. So enable wr and wr. So that's about it. Thank you guys for watching. We will start on a new topic soon. I'm pretty sure we fully completed our Windows Server topic, so we might move on to firewalls soon. I will think about some things that we can do more with our server here, but given the limitation that we have of my memory that we can use for my laptop's memory, there's only so much things we can do. We might move on to firewalls. I have still yet to decide what firewall I want to use, so I would either use for FortiGate or I would use a Palo Alto. But when we do, we will come back to this setup and we will incorporate a firewall to protect our network, and that would be the end of our project. Thank you guys for watching, and I'll see you guys next time.